Let's have a look at even and odd functions. And even and odd are basically just terms that we use to describe particular functions, just like how we have even and odd to describe numbers. So back in primary school, we may have been taught that even numbers like 10 are divisible by 2, and odd numbers are not divisible by 2. But when we're talking about functions, even and odd don't refer to whether a function is divisible by 2 or not. Instead, we have a new definition, and that's what we're going to go through today. And let's start with even functions. So the visual definition for an even function is that it's symmetrical about the y-axis, so like a parabola. And in terms of an algebraic rule that we can come up with, the rule for an even function is that f of x is equal to f of the negative x. That just means if you sub in negative x into the function, you're going to get the original function. But don't worry if that sounds abstract. Let's look at an example. So we have f of x is equal to x to the 4. First, let's have a look at this graphically, which pretty much just looks like a regular parabola, although it's a bit flatter at the bottom. But we can see that this is symmetrical about the y-axis. If we wanted to prove this algebraically, that this was an even function, what we need to do is first we need to sub in negative x into the function. So for example, f negative x is equal to, and then rather than writing x, we write negative x to the power 4. Negative x to the power 4 just means that we have 4 negative x's. If we wanted to look at two of these at a time, we would have 1x squared multiplied by another x squared, and that would be a positive x to the 4. And x to the 4 is basically our original function. So that means that our answer is equal to f of x. Or you could just remember that an even power always results in a positive number. That's the basics of even functions. Now let's have a look at odd functions. So odd functions, the definition for this is that it remains unchanged after a 180 rotation. And the equation that this needs to satisfy is that f of negative x is equal to negative f of x. So let's have a look at how this looks like in an example. We have f of x is equal to x cubed here, and the graph is shown here as well. So what I'm going to do is to rotate this graph 180 degrees. And we can see that we end up with the same graph if my drawing wasn't so bad. But anyways, we can further show this by doing some algebra and seeing if the equation for this holds. So we have f of negative x, which is equal to, we sub in negative x to the cubic power. We have negative x times negative x times negative x. And two of these negative signs are going to get you a positive sign. Since we have three negative signs here, the end result is also going to be negative, because there's nothing to cancel out that last negative. So we have x squared multiplied by negative x, and that is equal to negative x cubed. And if we look at what x cubed is equal to, that was our original function. So negative x cubed, another way to write that is just negative f of x. This has been an overview of even and odd functions. And here is a summary for future reference.